On this problem, they've given us a trapezoid on the x and y axis, and they want to know the area of that trapezoid. So it would help to first start by writing down the area of a trapezoid, which is one of the formulas they give us on our formula sheet. So that's going to be area equals 1/2 height times b1 plus b2. All right, so at this point, let's just plug some stuff in there. The h, that's the height of the trapezoid from bottom to top here. That looks like 5 units if we just count the squares. And now for base 1 and base 2, that's the bottom and the top, and it doesn't really matter which one you use for which. I'm going to let b1 be my lower base here. So counting from -2 to +8, that's a distance of 10. And then base 2 up top here, that's going to be a distance of 4. Now I just have to simplify this. So I can multiply these in any order I want. So I'm going to let me just do 10 plus 4 first. That's 14. 1/2 times 14, that would be 7. And then 7 times 5 gives me 35 square units. Choice B. On this one, we have a bunch of terms in a sequence given in a table and the values of each of those terms. We want to know which of these functions can be used to find the nth term of this sequence. So this is a good one for process of elimination. Basically, I'm just going to plug 2 into all of these different answer choices to see which ones I can eliminate right off the bat, which ones don't give me 16. And whatever's left over from that, then I'll go ahead and plug in 3 and then 4 and so on until I've only got one answer choice left. And I'm hoping I don't have to plug all of these into all of these, but hey, let's give it a shot. So let me start by plugging 2 into this 1.25n formula here. So we've f of 2, and this is a calculator question, but you may or may not need a calculator for this first one. 2 times 1.25, that's just going to be 2.5, which is not 16. So we can eliminate that answer choice. And now on to the next one. We're going to do f of 2 for this formula. So that's going to be 16 times 1.25 to the second power. And for that one, I am going to go to the calculator. So here's my calculator. Let me do 16 times, and now I need 1.25, and I'll close the parentheses, and I'll just press this squaring button here, or you can use the exponent hat button, either way. And that comes out to 25, which is not 16. So we can eliminate that answer as well. All right, this next one, I'm definitely needing a calculator for this. So I've got 1.24 times 1.25 to the second power. Let me go back to my calculator. So 10.24, parentheses 1.25, parentheses second power, and enter. That is 16. Okay. So this might be the answer that we're looking for, or it might not. So I could plug in 3 and 4 and 5 and see what this gives me, but it's going to be easier just to try out this last answer choice to see if I can knock that one out right away. So this is a maybe for C, but now let's try D. So we've got 3.125 plus 1.25 times 2. And I can see right away, even before I calculate this, that this is not going to give me my magic number of 16, but let's just do it out. So this is 31.25 plus 2.5, so that should be, I think, 33.75, but you can use the calculator if you want. Still not 16, so that's a no. So our maybe then is the only one left, so it has to be a yes, so that would be choice C. On this one, we have Grayson and Rosette, both collecting rare books. Grayson's got 23 and Rosette has 31, and they're going to add to their collections by, of course, buying more books. Grayson is a big spender, buying 3 books per week, and then Rosette, only 1 book per week. We want to know how many books they'll each own when their collections have the same number of books. All right, so the situation here, these are both linear situations. We're starting with a certain amount, and we're adding the same number over and over and over again. So one way you could do this problem, depending on the numbers, is you could create a linear equation for how many books Grayson owns and another one for how many Rosette owns, And then you could solve that linear system of equations using one of our time-tested methods, substitution, elimination, whatever. Even graphing, possibly, if you've got a grapher available. However, that's maybe a little overkill for this problem, because we're already starting with 23 and 31, and we're only adding like 3's and 1's. So it might be faster just to make a little table of values and just keep adding to the table until we get the same number. So that's what I ended up to do. I know it's kind of low tech, but I mean, sometimes low tech is the fastest way. So we started with 23 and 31 books, so 23 and 31. Grayson gets 3 more after that first week, and then Rosette gets 1 more, so that brings Rosette up to 32. After that, Grayson goes up to 29, and Rosette goes up to 33. Grayson goes up to 32 then, and then Rosette's at 34. So these numbers were already fairly close together. So now Grayson's going up to 35, and Rosette, 1 more, brings Rosette to 35. So they have 35 books then when they have the same number of books. Much faster than trying to solve a system of equations. For number 25 here, we've got the graph of a function shown here, and it's got some endpoints. We want the domain and the range. So domain, remember, is just the x values. We're going to go from the furthest left x value to the furthest right x value. So on the far left, we have -5. So I'm going to write -5 is less than or equal to, and then less than or equal to x, because these are x values. And I have the equals here because this is a solid dot, so -5 is actually part of my domain. It's actually one of my x values. Now moving to the far right, it looks like we're ending at the x value 3, and it's a solid dot there as well. So I'm going to write x less than or equal to 3. And there we have it. For the range, now we're looking at the y values. So because it's y values, instead of going left to right, we're going to go bottom to top, lowest to highest y values. So at the bottom here, this is the y value -3. And solid dot means we have less than or equals to. And we're going to put y in the middle there because these are y values now, not x values. Now at the top we have 5. So I'm going to, and it's another solid dot, so I'm going to write less than or equal to 5 for that part of the range. And there it is. On this one, we are given 2 triangles in the diagram, some measurements for each, and we're told that these triangles are, this little squiggly here means similar. So that means that their sides are in a proportion. The ratio of one pair of corresponding sides is going to be the same as the ratios for all the other corresponding sides. And then we want to figure out, based off of these measurements here, which of these proportions could be used to solve for x. The length of KL, that's this side right here. Notice that they don't actually want us to solve for x. They're just asking for the setup. Okay, well, one thing that might help us out here is if we know which sides went together and then put them in a proportion of some kind. So I'm going to start with the shortest side, at least what it looks like in the picture. So that's this KJ side. Now, you can tell which sides go together by looking at the similarity statement. The letters are written in a specific order. The sides that go together are in the same order in these 3-letter statements. For example, KJ, that's the first, or JK, either way, that's the first 2 letters. That goes with the first 2 letters in my other triangle, GH. So KJ and GH, those are corresponding sides, and it looks like they are anyway because you might notice these appear to be the shortest sides of both triangles anyway. So I can write the ratio 4.5 over 6. Right? That's one of my sets of corresponding sides. Now let me go through the other ones here. We've got KL, that's x, and KL goes with HI, high, that's 9. So I can write x over 9 as my next ratio, and we know these are going to be equal because, again, these are in proportion. These are similar triangles. And then let me get my last ratio in there. That's going to be my longest side, LJ, 9.75, and I'm going to do 9.75 over 13 because that's the other side that corresponds there. So 9.75 over 13. Now, when we're trying to figure out which of these proportions can be used, the basic idea here, now that you've got these these three things in this kind of double equation here is you're just asking which of these things could I get by rearranging one of the equations that comes from this little statement here. So you just have to kind of go through and use process of elimination. For my first one, I have 6 over 9 equals x over 4.5. So we're asking, could I get that from what I've written here? Well, if I have 6 over 9, so that means I would probably be using these first two fractions here. I could get 6 over 9 if I multiplied the 9 up here. So, or actually, no, I'd have to have the 6 get multiplied up here above the 9. So if I have 6 over 9 as one of my fractions, that means this x must have come downstairs to be under the 4.5. So that's not quite what we have in this answer choice. So that's a no. And then moving on to answer choice B, if I've got 13 over 9.7, 13 over 9.7, that means I'm essentially flipping everything here. So whatever else I write here, it should be one of these things flipped. So I could have 13 over 9.7 equals 9 over x, or I could have 6 over 4.5. So 6 over 4.5 isn't what we have here. And if I'm looking at this second fraction, if I write 9 over x to kind of follow suit with that last one, that also is not the same as 6 over x. So there's no way I can get a 6 over x. This one is also a no. And then let me look at this third one here. If I have 13 over 6, so now I'm involving the first and the last fractions. If I had 13 over 6, it meant I multiplied 13 to be on the top of this fraction, which means that 4.5 had to come down below the 9.75. If 9.75 is up here, it can't be down here, and there's no x in that one anyway, so this one's totally off base. Taking a look at my last one, I'm hoping this one makes sense. If I have 6 over 4.5, 6 over 4.5 is this first fraction upside down. That means that I should have one of these others upside down. This next one would be 9 over x, which is actually what we have here. So this one's a yes, so then choice D. For this multi-part problem, we have a marketing researcher surveying 1,000 shoppers about whether they watched a TV commercial and bought some shampoo. And here's a table with kind of the results. We have a row for people who watched the commercial and did not, and we have columns for people who bought the shampoo and did not. And there's 4 different possibilities based on whether they watched the commercial and bought the shampoo. First question, we want to know how many shoppers watched the commercial but did not buy the shampoo. So here's the watchers and the not buyers, and that intersects at this blank box right here, so we need to figure out this missing value. Now the key on this one is that we also have this last column here totaling up the number of people who watched or didn't watch the commercial. And there's also a bottom row totaling up the shampoo buyers and non-buyers. So we know that the 300 people who bought the shampoo after watching the commercial, or at least and watching the commercial, and the people who didn't buy the shampoo and watch the commercial, that has to add up to 750. So to find this missing value, that means I can do 750 minus 300, which comes out to 450 people. So I'll just put that in the table, and I can use that now for the next few questions. For question B on this one, based on the survey data, what is the probability that a randomly selected shopper watched the commercial but did not buy the shampoo? And how did we get our answer? So a randomly selected shopper, that's the key, is we're looking at all 1,000 people and watched the commercial but did not buy the shampoo. That is, again, this 450 that we just found. So we have the group of people that we're looking for, the 450, divided by the total number of people possible. And again, we're selecting a random shopper, not a shopper who bought the shampoo or watched the commercial or whatever, just a random shopper from the overall pool of 1,000 is how this reads. So we need 450 over 1,000 for this one. And then if you want, you can reduce that, or you can turn it into a percentage. This is 45% if you go ahead and divide that. For part C, based on the data, what's the probability a shopper bought the shampoo, given that the shopper watched the commercial. So bought the shampoo and watched the commercial. Bought the shampoo, watched the commercial. That's this 300 right here. But now we have to figure out the denominator. Notice that this is not just some randomly selected shopper. They are focusing on the shoppers who watched the commercial. So when we're asking what this 300's out of, it's not out of the 1,000. This is only out of the 750 who watched the commercial. These other 250 don't even enter into it. So this is going to be 300 over 750 then, which we can turn into, let's see here, this would be 2 out of 5 or 40%. For the part D on this one's a little bit trickier because we have to do a little more reasoning based off of this graph. They're asking, based on the data, are watching the commercial and buying the shampoo independent events? Show or explain how we got our answer. So if these are independent events, that means they shouldn't affect each other at all. Looking at the data here, so basically I'm asking, does the decision on whether or not somebody watched the commercial affect whether or not they buy the shampoo? So if I take a look at the number of people who watched the commercial and how it broke down, buying versus not buying the shampoo, that was 30 out of 750. So 40% of them who watched the commercial ended up buying the shampoo. Now, if I look at the other people who didn't happen to watch the commercial, 50 of them bought the shampoo out of the 250 who are in this category. So I can't just look at like the 300 versus the 50 and say, watching the commercial makes you more likely to buy the shampoo, because we have to kind of compare, this 300 to the total number of people who happened to see the commercial. Same thing here. We have to compare this 50 to the total number of people who happened to not watch the commercial. But taking a look at this, like watching the commercial, 340% of them bought the shampoo. Those who didn't watch, only 20% of them, 50 out of 250, ended up buying the shampoo. So based off of that, we can say people who watched the commercial were more likely to buy the shampoo, 40% versus 20%. Because of that, it would seem that these are not independent events. It seems like somebody who happens to see the commercial is more likely to buy the shampoo, twice as likely, based off this table, than somebody who doesn't happen to see the commercial. On this one, we have a triangle Q shown on a coordinate plane, and we basically want to, it says, reflect that over the x-axis. So what does that look like in terms of this other triangle P? All right, so let me just do some reflection over here. So let me start with this point here. I'm going to flip that over the x-axis, so that goes to right about there. This other point comes up right about here, and this last spot on the original triangle is going all the way down here, again, if I'm reflecting that over the x-axis. So here's what that triangle looks like. So just looking through my answer choices, it looks like that's probably A. Let me just look at my other ones, though. Definitely not B. It's not even on the correct side of the axis there. Definitely not C. That one's not facing the right way. D is also not even on the correct side, which also happens to be the right side of the y-axis. So I'm pretty confident about choice A. For this one, we have John, Maria, and Robin going to the same school, and at the end of the school day yesterday, they walked directly home at a constant rate. And the functions in this table that they gave us here tell us how far they are from home in miles after walking for 8 hours. So you'll notice these are all basically kind of y equals mx plus b sort of situations. We have our starting value, the miles that they started from home, 0.9, 0.6, 1.1, and then that's being decreased per hour based on how fast they're walking. And then we have a bunch of different statements about the table trying to establish, 2 of these that are true. So what I'm going to do to sort of make sense of all these, since they're all talking about, how far we are from school and who's going the fastest or the slowest, I'm going to just make a table here for John, Maria, and Robin. And I'm going to explicitly write down their distance from home and their speed, just to make it a little easier to look at. So the distances are all these constant values because when h equals 0 at time 0, when they first start out, this minus term here is going to go away, and you're just going to be left with this constant. So that's telling us that John is starting 0.9 miles from home, Maria is 0.6, and then Robin is 1.1. Now the speeds are just the numbers that are being subtracted next to these h's here. So it looks like John is basically walking like 3.5 miles per hour. So we're losing 3.5 miles off the total distance every hour. So we can say 3.5 for John's speed. This will then be 3.7 for Maria's and 3.7 for Robin's. Given that table, let's go ahead and analyze each of these statements to see if they make sense. So first statement, John lives closest to the school. Looking at our distances here, the smallest distance, the closest to the school, actually belongs to Maria. So since that's Maria, not John, that is not a true statement. Next one, Maria walked at the slowest rate. Looking here, the slowest rate of 3.5 belongs to John. John is the slowest. So it's not Maria, so that's also a no. Next, Robin lives farthest from the school. Looking back at our distances, Robin has 1.1, which is more than anybody else has for distance, so that's true. That'll be one of our two correct answers. Next one, Maria and Robin walked at the same rate. So the speed for Maria and Robin is 3.7 for both of them, so that's also a true statement. They told me there were two correct answers, so this last one probably isn't true, but let's just double check it. Maria and Robin live the same distance from school. So Maria's 0.6, Robin's 1.1. Those are not the same thing, so that's a no. So that confirms that we are indeed choosing choices C and D. For this problem, we have a little bit of a construction going on. They've done the construction for us and detailed all the steps they took, and we have to figure out what's true or not true based on what we've got here. So the basic idea is they took a circle, and using a compass and a protractor, they first drew this J to L diameter here. Then they stuck their compass at the J and the L, and they used it to do these arcs. Where these arcs crossed, they drew another diameter through those, which they called KM. And they also drew lines from J to K, K to L, L to M, and M to J. Based off that, we're trying to figure out one of these statements. So this is kind of a process of elimination thing. So first statement here is KM greater than JL. So here's KM, it's one of the diameters. JL is the other diameter. The diameters, since they are diameters, since they are the distance across the circle, and it should be the same distance across no matter which way we go, those should be congruent. Since our diameters are always going to be congruent, that means that one could not have a greater length than another. They would always be equal. So that is actually a false statement right off the bat, and we were looking for the statement that was not true, so we could stop here and call it a day. But just for education's sake, let's look at the other choices and see why these are actually true. So I'm actually going to look at these a little bit out of order. The first statement we're looking at is JKL, that's JKL, that's this angle here, and they're saying it's congruent to KLM. Now, to show those are congruent, it would be helpful to know what kind of angles those were, but that's kind of hard to tell if we haven't really talked about what sort of shape this whole JKLM is. So let's go down to choice D, where it says quadrilateral JKLM is a square. Is there any way to prove that this is actually a square? It turns out there is. We already know from what we did in choice A that the diameters, which are the diagonals of this quadrilateral, are congruent. They're the same. In addition, just the way that these were drawn, since we drew this diameter where these arcs are intersecting, we know that K and M are the same distance away from J and L. This distance here and this distance here are the same. That tells us that all these distances we drew, these segments we drew between them, since K and M are the same distance from J and L, all these distances around this quadrilateral must also be the same length. If you have all the same sides being congruent and your diagonals are also congruent, that means you could only be dealing with a square. If you just had the four sides being congruent without talking about the diagonals, then you might have a rhombus as well. A rhombus has four sides that are congruent. But the diagonals cement the deal. Once we've established that this is a square, we can actually talk about what types of angles all these angles are here. Squares have right angles. Since this is a square, that means that KJM and all the other angles are all right angles. So statement C is also true along with D. Now we go back to B. B again is talking about JKL, this angle up here, and this rightmost angle, KLM. Well, we know now from what we did down here that these are going to be right angles. Right angles are always 90 degrees. They're always the same length. They're always the same measure. So because those are right angles, they must also be congruent. So this is also a true statement. So we can confidently pick choice A. On this problem, we have the functions f and g both graphed on the same plane, and we want to do some statements about them and analyze these statements. All these statements are talking about which function is greater than which other function and the places where that is true. Because you might notice here, since these are intersecting, the function that is higher up for part of it is not consistent. It changes here at x equals 2. So let's look at each of these in turn. For x less than 2, so to the left of this intersection, this statement is saying the value of f of x is greater than the value of g of x. F is this blue line here. F is actually less than g of x. The blue line is lower y values than the solid black line. So this is a false statement. F of x is actually less than for that interval. Now let's look at the next one. For x greater than 2, got to read carefully here. So now we're at the right of the intersection. The value of f of x is less than the value of g of x. Well, less than means lower than. To the right of this intersection, f is actually above, not below, g of x. So this is also a false statement. And then finally, for x greater than 2, the value of f is greater than the value of g of x, pretty much the opposite of this last statement, and that is in line with what's happening here. F of x is higher than g of x after you get to x equals 2. So that was our only true statement. For this problem, we have a table of 9th and 10th grade students and which season they picked as their favorite. It's a two-way table here. The question is, what percentage of students surveyed chose fall as their favorite season? So we're talking not just about the 9th or the 10th graders, we're talking what percentage of all of the students, because they weren't specific, chose fall. So fall total is this spot right here. It's in the total row, and it's under fall. So that's 86 students overall who picked fall as their favorite. Now, what should we divide this by? 86 over what? Well, we're talking about the total students, not just the 9th graders or the 10th graders. The total students was 376. So we need to use our calculators now, looking at our answer choices, and do 86 divided by 376. So here's my calculator. Running those numbers, doing that division, I end up with 0.229 if I round that off. Move my decimal 2 places to get a percentage. That's going to be 22.9%, which is choice A. For this second part of our problem here, they want to know what percentage of students who chose summer as their favorite season were 10th grade students. So in this case, we're looking for an intersection of those things. Here's the summer students who were 10th graders, so there's 71 of those. But now we're not asking what percentage out of the total student body, which would have been 376. Now we're just asking what percentage out of students who just chose summer as the favorite season. So we need to do 71 over 151 and come up with that percentage. So here we go, plugging that into the calculator, 71 divided by 151, and that comes out to 0.470. So we're going to call that like 47.0 if we move the decimal over 2 spaces, and there we are. For this circle problem, we have our circle here with a triangle drawn in it. And this angle of the triangle is 40 degrees, and we've also got this arc, a minor arc, ZY or YZ on our circle, that's 120 degrees. Based on that, we want to know the measure of minor arc XY. So we're asking about this arc down below. We know it's this arc because, for one thing, there's only 2 letters in it. So that matches this. If it were this other XY, we would call it XZY, not just XY. But also, we know this is going to be a minor arc because it's got to be less than 180 degrees. This line is not a diameter, so that means that we're dealing with less than half the circle here. Okay, so how do I find this measure? There's a lot of ways to do this. One way to do it would be to figure out the measure of this angle Z and then double that to give you the intercepting arc here. That's one way to do it. Another way to do it would be to figure out this other minor arc up here and then just add that with 120 and subtract it from the 360 degrees that it takes to get all the way around the circle. I used the second approach. So because this arc is opposite from this inscribed angle of 40, I know this here is going to be twice 40, or 80. And now I'm just going to do 360 minus the 80 and the 120 that I've already used up on the top of the circle. So that's 360 minus 200, which comes out to 160, which is answer choice C. For this 4-part question, we have Ellis running around a track at a constant speed. Distance around the track is a quarter mile, and it takes Ellis 3.2 minutes to run around the track once. We want the total time in minutes it takes Ellis to run 1 mile, given that it takes Ellis 3.2 minutes to run a quarter mile. So assuming that Ellis can keep up whatever the speed is here, since we've already got a quarter mile at 3.2 minutes, we can just multiply this by 4 to figure out a whole mile, 4 quarters. And you are allowed to use a calculator on this. I don't need one myself for this part of it, but it's fine if you used one. This ends up being 12.8. And we have to use our units here, so total time in minutes. So this is 12.8 minutes to go a whole mile. For the second part of the question, we want the total distance in feet that Ellis runs in 1 minute, and then explain how we got the answer. So in general, we're asking for a rate here. It's basically feet per 1 minute, feet per minute. So one way you could do this would be to take the distance gone and divide that by how long, and that would give you your rate. The trouble here is that they want this rate in feet per minute. They gave us miles for the initial units, so we have to convert that into feet. We can do that if we multiply the 1/4 by the number of feet in 1 mile, which is 5,280. That's one of those facts you can look up on your reference sheet. So let's see what that comes out to on the calculator. And to figure this out on the calculator, I'm just going to do 5,280 divided by 4. That comes out to 1,320 feet. So that's the distance around the track. If I want to know how long Ellis runs in a single minute, I can just divide the total distance by the total minutes by 3.2 minutes. And let's see what that comes out to on the calculator. So I'm just going to press divide because it's already loaded my 1320 in as an answer. So divide by 3.2, and that's going to be 412.5. So 412.5 feet in 1 minute. For the next part of this question, I want the rate in miles per hour that Ellis runs around the track. So good news and bad news. The good news is I've already got Ellis's speed from part B. Remember that was 412.5 feet per minute because that's how long Ellis ran in 1 minute, so that's actually a rate. The bad news is I've got the wrong units. I've got feet per minute right now. I need to convert that to miles per hour. So I have to convert the feet to miles and the minutes to hours. There's a lot of ways to do this. To make my life easy, just because this is how I think about things, I'm going to set this up as a fraction and multiply by some kind of unit conversion fractions. So I'm going to write this as 412.5 feet over 1 minute. And the first thing I'm going to get rid of is the feet. So to convert that to miles, I'm going to multiply that by the unit conversion factor that has 1 mile over 5,280 feet. And if I multiply by this, down the road, my feet are going to cancel. Now, before I do that, I also want to make sure I'm converting my minutes to hours. There are 60 minutes in 1 hour, so I'm going to write multiply by another fraction that has 60 minutes over 1 hour. That's going to cancel out my minutes and leave me with hours in the denominator. So going through and doing all that, my feet are canceling, my minutes are canceling, and now I just have to multiply all this out and see what it comes out to. Let me do the numerator first. So I've got 412, or 0.5, times 60. That comes out to 24,750. And the units up there right now is going to be miles, but obviously, we're going to change that around. And now downstairs, I've got 5,280 hours. So let me go ahead on my calculator again and divide 24,750 by 5,280. And that's 4.6875. Not sure what I need to round to. I'll go out 2 decimal places here. So 4.69, and that's going to be in miles per hour. For the final part of this question, Ellis will apparently run 40 minutes every day for 5 days with a goal of getting up to 15 miles. Will Ellis meet this goal? Explain the reasoning. Lots of ways to do this problem. One way, since you already have the how many feet Ellis runs in a minute, you could multiply that by 40 and then by 5, come up with the total number of feet Ellis runs over the course of 5 days, and then convert that to miles by dividing it by 5,280. Another way you could do it is figure out how many minutes Ellis runs for, convert that to hours, and multiply it by Ellis's hourly rate that we found in Part C. I chose the second approach just because we just did it. I did all that work in Part C. I want to use it for something. So there was our Part C answer, rounded off, 4.69. And let's see how long Ellis has been running for. 40 minutes times 5 days gives us a total of 200 minutes. And then if I just divide that by 60 to convert that to hours, that's going to be, I can just do this on my calculator, but I could probably do it without one. Let me use the calculator, though. So I've got 200 divided by 60, and I'll round that off to about 3.33. That should be accurate enough for this problem. So if I've been running for 3 1/3 hours, and I multiply that by my hourly rate of 4.69, let's see what that comes out to on the calculator. So 3.33 times 4.69. That comes out to 15.62 if I round that off. That's how many miles we ran. Now that is greater than the 15 miles that Ellis was trying to get to. So Ellis, you overachiever, you exceeded your goal. So definitely then you're meeting your goal of 15 miles. On this problem, we have some triangles and their measurements shown in the diagram, and we want to know which of the following things here is true. And this is a 2-part problem. This is just the first part now. So we were talking about angles and sides being congruent. So it might help to know before we dive into this whether these triangles are congruent. Notice that they never actually said that the triangles were congruent. There was no statement. So if we're going to try to use that fact, we have to prove it first. Taking a look here, it looks like we have 2 angles here and 2 angles here that are congruent, and the side between them is also congruent. So by angle, side, angle, that's one of our ways of showing triangles are congruent. By the angle, side, angle postulate, the triangles are congruent then. So that means if the triangles are congruent, that all of their corresponding sides and angles are congruent. So we can go back to the diagram and start labeling the angles and sides that go together. So I know that these, let's get the angles now. That means this third angle must be congruent. In fact, we already kind of knew this because if 2 angles are the same, there's only the same amount left over when you subtract from 180 for that third angle. So we also could have proved that the triangles were at least similar by angle, 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 but that wouldn't be enough for congruence. Anyway, we've got these angles. Now we also know that the sides that are across from corresponding angles are also going to be congruent. So for example, the side across from this double arc angle here, this side and this side here, those are both congruent, so I'll mark those accordingly. And then the sides across from this single arc angle are going to be congruent, this long side of the triangle, at least that's what it appears. So I'll give those like a triple line to show that those are the same. Now that we know what lines up with what, let's look at our statements. Choice A, E and Y are congruent. Here's E, here's Y. We have a double arc versus a triple arc. Now, we can't really prove that they're not congruent. They might be, for all we know, but we can't prove that they are congruent. So we can't choose this. It doesn't have to be true. It could be true, but it doesn't have to be. There are a different number of arcs there. Next one, choice B, G and Z, those angles, saying that those are congruent. Well, G is a triple arc, Z is a double arc. So again, those are not necessarily the same angle. And then C, EF and YX, congruent. Here's EF, it's a single line here. And then YX, that's this one right here. That's a double line segment. We have a different number of hash marks there, so those are not necessarily congruent. So it's down to choice D, FG and XY. FG is a double hash mark, and XY, this one here, also a double hash mark. So those have to be congruent based on everything we said before. So choice D. For this next part of the problem, we have a diagram showing triangle JHK and some of its measurements. They want us to compare this to EFG and then put the angles in order basically to make this congruent statement true. So first thing to recognize here is that since we have the same two sides, 13.3 and 6.5, and the same angle between them, 37, as we have in triangle EFG, by side angle side, we know that these two triangles are actually congruent, which is great. It means that we can count on their corresponding angles being exactly the same. So I'm going to go ahead and label those angles because that's really the key to answering this question, is basically writing this in the order of the corresponding angles. So starting with, let's see here, my single angle arc over here in EFG was across from 13.3, so that's angle K over here. And then my double arc angle was across from the 6.5. So looking over here, that's going to be H across from 6.5. And then finally, that means that this 37-degree angle is our triple arc angle from EFG. Now let me write these in order, the order that they gave me with this EFG statement here. So looking first at angle E over in the first triangle, that's the double angle there, the double arc angle. So I have to match it up with the double arc angle over in JHK. That happens to be angle H. That's also been labeled with our double arc. So I'm going to put an H right there. And next, angle F, looking over in my first triangle, that's the single arc angle. So over here, single arc is angle K. And then finally, we have G, that's the triple, and the triple over here, the only one left is J. So we have HKJ congruent to EFG. For this problem, we have a customer purchasing a pumpkin at a farm stand, paying $1.38 per pound for the pumpkin, and then we're told that the mass of the pumpkin was 4.8 kilograms, rounded to the nearest tenth of a kilogram. So that's kind of interesting that they have a price per pound, but then randomly the mass is in kilograms, which is a totally different measurement system. But hey, whatever. Let's do some conversion. We want to know the total amount the customer could have paid for the pumpkin. And the could is important here. We're going to do this out as accurately as possible, but we might not get an answer that's exact. They said that they rounded the kilograms to the nearest tenth, so who knows? All right, so let's start by figuring out what our measurement is in pounds for this pumpkin. So first off, from our reference table, we have the conversion factor that 1 kilogram equals 2.2 pounds. So that is right off the MCAS reference sheet. We can always look that up. So let's go ahead then and take our 4.8 kilograms and multiply that by 2.2 to figure out how many pounds we have. Going to my calculator for that, we have 4.8 times 2.2. And that comes out to, I'm going to just do exact here. It's not too many decimals. So we have 10.56. So that's our pounds. Next, we're told that the price is $1.38 per pound. So let's just do our pounds, 10.56 times the 1.38, and see how much money that should be. So going back here, I'm just going to do press the multiplication because it stored my answer. So times, and now let me do 1.38, and that comes out to roughly $14.57 if we round that off to the nearest cent. Now, looking at our answer choices, none of these match exactly, but choice D is pretty close. And I think, so choice D is only about 10 cents, 11 cents off. I think it's much more likely that choice D is the answer than any of these others that way undershoot the value we got. So let's go with D. For this problem, we have Gavin and Heidi both working part-time jobs during the summer, and we have these line plots showing how many hours they worked per week over an 8-week period. So it's not consistent. They worked either 11 hours or 17 hours or whatever. Now, what we want to do here is compare the centers and spreads of the two data sets. And ultimately, we want to figure out who had the bigger median, who had the larger mean, and who had a greater spread of the data. So I'm going to start making a table here just so I can organize all this. Then I'll just look at my table and go through and pick things off my list. So let's start with the median. That's not too hard to figure out with these line plots. The idea with median is that you have to have your data sorted in order, and then you cross off things from each end until you get to either one item in the middle or two items in the middle, and if there's two of them, you just average those together. Now, the nice thing about a line plot is that everything is already in order. So let me start with Gavin, and I'll start crossing some things off. So we have an X here and one of these X's, and then one of these and one of these, and then this X here and one of these in the 18 column, and that leaves us two of these X's in the 18 column. Now again, if there's two items in the middle, we average them together. The good news here is they're both 18, so the average is going to be 18 for Gavin's median. So let's go with 18 for that. Next, we'll do the same process for Heidi's line plot. So we have this X and this X at 20 being crossed off, and then a 14 in one of these 19s, and then a 17 in one of these 19s. And then that leaves us with the 18 and the 19 left in the middle. The average of those, the number that's directly in the middle of those, is going to be 18.5. But if you wanted, you could add it on your calculator. 18 plus 19 is 37, and dividing that by 2 gives you 18.5. All right. Now, if you wanted to use your calculator on that, you're going to get to use your calculator a whole bunch on the next one. For the mean, we have to actually basically write out all the data items, add all of them together, and divide by the number of data items for each of these two sets. So let me do Gavin first. I've got an 11 here, and there's 8 of these, by the way. We have 1 and then 7 over here. So we're eventually going to divide by 8 after we add up all of Gavin's hours. So we have an 11, and just to save a little space, I'm going to do 2 times 17, because those are identical, and 3 times 18, and then finally 2 times 19. That'll also save me a little bit of trouble on the calculator. Not a lot, but just enough. Let me go ahead and calculate that now. So off camera, I've entered all the stuff in this numerator into my calculator to see the grand total of hours, and that came out to 137. So we've got 137 divided by 8, and I'm going to actually want to divide that by 8 on the calculator so I can get a more or less exact answer. So it's roughly 17.13, 17.1. So we'll put that in our chart here. So there's Gavin. And now let's do the same thing for Heidi. So Heidi also had 1, 2, 3, 4, 5, 6, 7, 8 items. Let's add those up now. We have a 10. We have a 14, a lot of different numbers here, 17, 18, 3 of these 19s, and then a 20. Let's add all that up. So plugging that all in off camera, all of Heidi's hours added up to 136. And then let me just divide that by 8 to get exactly 17. Nice. All right. So we've got most of this filled out. Now let's look at the spread. Now, if we wanted to super accurately calculate this, we would find the standard deviation for each of these data sets, and you could do that. But I think it's easier, especially with these ones, just to kind of eyeball them and basically take a look at which one seems to have more spread out data. So just looking at Gavin's, it looks like most of Gavin's hours are sort of clustered in the 17 to 19 range, whereas Heidi's hours are definitely more spread out. There's only one number of hours where Heidi has more than a single entry, and that's in 19. So I would say that Gavin is more or less spread out, rather, and Heidi is more spread out. We don't have to give it an exact number because we're just comparing the two. So let's go down to our drop-down boxes here. So the median between the two of them, it looked like Heidi had a greater median. So we'll circle Heidi there or select it. And then the mean, it looked like Gavin had a slightly higher mean. We had to be pretty accurate on that one. So we've got Gavin. And then for the spread is greater, more spread out for Heidi. So there we go. For this problem, they're giving us a pentagon here on the coordinate plane. And they're telling us that this pentagon is going to be translated up 3 units and then reflected over the y-axis to create another pentagon. We want to know which best represents the coordinates of point T prime, which is basically what happened to point T after all these transformations. So there's a couple ways we could approach this problem. One would be to perform both of these transformations on the entire pentagon and draw a new pretty shape, and then look at point T on that new shape, or I guess it'll be T prime at that point, and see what coordinates it is. Option B on this one would be to just do the transformations to point T and forget about the rest of it, because that's really all they care about is where point T ended up after these two. So let's do that. First off, let me mark point T. It's right here. Currently, we are at -2, -1. And now if we translate this up 3 units, we're going to count up 1, 2, 3. That brings us to -2, 2, which is one of the answer choices. That's there to fool you because we're not done yet. We still have one more transformation. We have to reflect this over the y-axis. So here's the y-axis. We are 2 away from the y-axis over to the left. So we're going to go 2 away from the y-axis over to the right. And that brings us to the point 2, 2. And that represents answer choice D. For this 2-part problem, they're giving us a circle with radius of 7 inches, and we have a sector that's got 60 degrees carving it out. And we want to figure out for this first part the area of that shaded sector. Okay, so probably a good place to start would be to find the area of the whole circle, and then once we know what the whole picture is, we can just take a small piece of that pie and figure out its individual area. So for the whole circle, the area in general is going to be area equals pi r squared, and that's right off of our MCAS formula reference sheet. Now for the radius for the circle, we've got 7. So we've got pi times 7 squared. And I'm just going to call this 49 pi for now. I could come up with a more precise looking decimal, but there's really no point because I'm going to be moving stuff around and I don't feel like messing with the decimal a second before I have to. All right, so how do we get from this general area to just this small piece of it? So the area of the sector is going to be proportional to how many degrees we're taking up with this 60 degrees. So in general, we can say that the sector area over the circle is going to be in the same ratio as 60 over the total number of degrees in the circle, 360. You're basically figuring out what fraction of this circle you have, and the degrees is going to tell us that. So for the sector area, I'm going to use K to represent that because I've already kind of used A for circle area. And then the circle itself, we found it had an area of 49 pi. So I've got K over 49 pi equals 60 over 360. If you wanted to make your life a little bit easier and didn't have a calculator, you could reduce this to 1 over 6 over here, but I'm not going to bother. So multiplying now, I'm going to cross multiply to get k by itself. So I've got 360k, and then whatever 49 pi times 60 is. Let me look that up on the calculator. So on my calculator, for now, I'm just going to do 49 times 60, which comes out to 2940. And I'm going to put a pi next to it. Again, I'm not going to mess around with decimals a second before I have to. But now I'm at the point where I do need a decimal. I've basically got to divide by 360 to solve for k. And I need to get one of these decimal answers. So going back to my calculator, I've already got 2940. I'm going to now multiply that by pi. And I can get that by doing, let's see, second and this exponent button. It might be different on yours, but there we go. So that comes out to some crazy wackadoodle decimal that I don't really care about. But I'm going to divide this now. Divide by 360. And that gives me about 25.7. And apparently that's in square inches, those units. So let's go with choice A. For part B of this problem, they want to know the length of this minor arc XZ. So this is actually kind of the same problem we just did, only we're asking about a piece of the circumference now instead of a piece of the area. But it's going to work the same way. If we can find the circumference of the whole circle and then just take basically 1/6 of that, because 60 out of 360 is 1/6, we're going to get our answer. So in general, our circumference is going to be 2 pi r. In this case, again, r is 7, so 2 pi times 7, or 14 pi, because I don't feel like messing with decimals yet. And now the arc length over the circumference is going to be the same ratio as 60 over 360. Also the same ratio as the sector area over the whole area, but we don't really need to mess with that. So for arc length, I'm going to use the letter L to represent that. Circumference we just found was 14 pi. So I've got L over 14 pi equals 60 over 360. And just like I did on part A, I'm going to cross multiply to get this missing variable. So I've got 360 times L equals whatever 60 times 14 is. So let me, and with a pi next to it, let me go to the calculator for that. So we have 60 times 14 is 840. So we have 840 pi. And then let me divide 840 pi by 360. So back on my calculator, I haven't multiplied by pi yet, so let me do times, and again I have to do second exponent button. Now if you're having trouble finding the pi button, you can just do 3.14, and it should get you accurate enough of an answer to get one of the answer choices, or at least for write an answer for this problem. So now we have to still divide this by 360. So divide by 360, and that comes out to, I'm going to use two decimals here, so 7.33, and my units is going to be inches. So now let's just do one decimal, 7.3 inches. For this one, we have the value of a car being modeled by this exponential expression here, and x is the number of years since the car was purchased. So this will give us our price in dollars. Now you might notice that we have this exponential variable here. So we basically keep, as the years go on, we keep multiplying by 0.86 over and over again. And in general, that's going to cause the price of the car to go down, which is what we would expect. Cars tend not to go up in value as they get older. So we want to complete the sentence from our drop-down menu. In the expression, the 18,000 represents what? So if we were to plug in 0 for x, anything to the 0 power would just be 1, and this 18,000 then would be the original price of the car. So that's going to be the purchase price of the car is how they're wording that. That's what we start at. If we just plug in 0 for x, we're just going to get 1,800 back. Now the 0.86 represents which of the following? So it has nothing to do with the price of the car. It's either the decay factor or the growth factor. Now the difference is going to be, again, is this, as we multiply by this 0.86, is our number going up or down? Since this is less than 1, or I should say between -1 and +1, that means we're going to be going down every time we multiply by this. So that means this is going to be a decay factor rather than a growth factor. For this one, we are given a right circular cone, and they said some of its measurements. They literally just gave us the 9-inch height, and that was it. Oh, they also told us, though, that the volume was 432 pi cubic inches. That's kind of an interesting way to express the number. Based off this, they want the radius of the cone. So it would be great to start with the formula for the volume of a cone, because that also has the radius and the height in it, so we could probably work backwards on that. So looking that up in your reference sheet, you will see that that is volume V equals 1/3 pi r squared h. It's okay if you didn't have that memorized. Again, they give you the formula sheet for a reason. So now we're going to plug in as much information as we have for this and see if we can solve for the radius r. Now the volume, they did give us that. That was 432 pi. Don't forget that pi there. We didn't get anything for the radius. That's what we're looking for. So I'm just going to rewrite equals 1/3 pi r squared. Pi is its own thing too. We don't need to plug anything in for that. And now for height, h, that's this 9 inches right here. So now let's see if we can work backwards and find the value of r. I'm going to start by simplifying the right side of the equation. So I can do 1/3 times 9 is 3. So 3 pi r squared. It's a little bit easier to look at now. And I'm going to now get the r squared by itself by dividing by 3 pi. So dividing by pi cancels those pi's out, which is rather nice. And 432 divided by 3, not really sure what that is. Let me look that up on my calculator. 432 divided by 3 comes out to, nice, 144. That is a very good number to have in this situation, because the next thing I'm going to have to do to get r unsquared is to square root it. And 144 is a perfect square. The square root of 144, I just happen to know, but you could do it on the calculator, is 12. So that means our radius is 12 inches, which allows us to pick answer choice C. For this problem, the last problem on the MCAS here, a teacher claims there's a strong negative correlation between the amount of time students spend playing video games and the amount of time students spend playing sports. The teacher conducted a survey, collected data, computed an equation for the line of best fit for the data. We want to know which of the following correlation coefficient values for the data would best support the teacher's claim. So this is actually a very easy question buried under a lot of just wordage here. So the teacher's claim, looking back at the very beginning, the teacher claims there's a strong negative correlation. So if we're looking for a strong negative correlation, we are looking for a more negative correlation coefficient when we go ahead and actually write out the equation of the line of best fit, which, by the way, is just the equation of a line. So we want the most negative answer, essentially, to support the teacher's claim. Looking at our answer choices, the most negative choice is choice A, negative 0.9. B is a little bit negative, not negative like that, though. And then C and D aren't even negative. They're both positive. So let's go with choice A.